Welcome everyone to West Explains Best. Hope you've been having a great new year so far. Today we're going to be talking about section 6.4, rhombuses, rectangles, and squares. Oh my! So we have three different shapes which are all classified as parallelograms. Let's go ahead and get started. So these are the special parallelograms. The reason why they're special is because not only are they classified as a parallelogram, but they have an additional attribute, and we're going to see what those are in just a moment. First up, we have the rhombus, also pronounced rhombus, depending on who you talk to, but both are correct. And it is a parallelogram, and I'm going to abbreviate it with this, and I'll put it here just so you can reference it, parallelogram. That's the symbol for it, in case you see that in your book. A parallelogram with congruent sides. So it's the same thing as a parallelogram meaning it has opposite sides that are parallel, but the additional feature is that all the sides are congruent. So if we go here to the diagram, not only do we have these sides parallel, okay, and these sides parallel, okay, so that's what we already knew about parallelograms, but we also knew, or now know, that the sides are congruent. So all these sides are congruent. They all have to be the same length to be a rhombus. And that's our first special parallelogram. Our second one is a rectangle, and it is a parallelogram, now we know what this means, with congruent angles. So rhombus with congruent sides, rectangle is congruent angles. And since a parallelogram is a shape with four sides, that means it has a total sum of angles of 360 degrees. So if we do 360 degrees divided by four angles, 1, 2, 3, 4, then we know that each one needs to be 90 degrees if they're all going to be equal. So a rectangle has 90-degree angles, and of course, because it's a parallelogram, opposite sides are parallel. Okay, rectangle, second special parallelogram. Last one, a square. This one is the most special, and that's because it's a parallelogram with congruent sides and congruent angles. So it's got both. It's got the features of both the rhombus and the rectangle. So let's draw our parallel sides here and here. Okay, and then we're going to draw our congruent angles and sides. So all the sides are the same length and all the angles are the same measure, congruent sides and congruent angles. So the square is really a special type of shape. So we have this awesome drawing here. It makes me want to redraw it. Let me do that real fast, actually. So I'm going to redraw this real quick. So we have this wonderful shape here, okay? And then we're going to have this wonderful shape here. Let me just copy and paste it, actually. Copy, paste. Okay, so we're making a Venn diagram. So in our Venn diagram, we need to change the color here. We're going to have two different shapes being represented with these two different colors. Okay, so in our first shape, okay, we're going to style this, actually. We're going to fill it with pink if it's not too much trouble. There we go. And we're going to style this one with green, and we'll see how they overlap. They don't have the overlap I intended, actually. So we're going to go back. There we go. So with the green, we're going to call this the rectangle. So we have a rectangle here. And then for this one, we are going to have the rhombus. So we have two different shapes. This we have the congruent sides. For this one, we had congruent angles. And this is just a way to represent the intersection between those two. What is the shape that represents that intersection? It is the square. It represents both because it has congruent sides and it has congruent angles. So a lot of these shapes can be represented with Venn diagrams, and this is just another example. So here we go, rhombus diagonals theorem. What is this talking about? ABCD is a rhombus. If it is a rhombus, okay, and we can see that it's a parallelogram, okay, with congruent sides, then what? Well, what's special about a rhombus is that its diagonals have a special property Okay, and I'm going to draw one diagonal here. Draw a second one. Okay, the special property is the two diagonals will meet at 90 degrees. So, we can say diagonals are perpendicular to each other. Okay, so that's the first property. If we have a rhombus, then the diagonals are perpendicular to each other. That is the special feature about rhombuses. So number 2, rhombus diagonal bisecting theorem. What's that about? If it is a rhombus, okay, what color did I use? Purple. So if it is a rhombus, then let's draw our diagonals, okay? We're going to draw our diagonals again. This time we can say that angles 1 and 2, okay, are going to be congruent, and angles 3 and 4 are going to be congruent. So we can say with certainty, actually I want to change the color of that. I want to make it red. So we're going to say 1, 2, 3, 4. So angle 1 is congruent to angle 2, is congruent to angle 3, is congruent to angle 4. And then we have more angles. Okay, we'll have 5, 6, 7, 8. So angle 5 is congruent to angle 6, is congruent to angle 7, is congruent to angle 8. Now, what's a way to say that more concisely? Is that the diagonals bisect the vertices. So each angle, each vertex is bisected by the diagonal to create equal angles. So these angles are equal, okay? These angles are equal, these and these are equal, okay? Those pairs, those sets, actually it's 4 that are equal. So we're going to apply it now. So in example 1, we're asked to find angles 1, 2, 3, and 4. The first one you should start with, if this is a rhombus, and you know it's a rhombus because it's a parallelogram, really we should have these little parallel signs in here. But if it is a rhombus, then we know angle 1. Angle 1 is going to be 90 degrees because we know that rhombuses have diagonals that meet at perpendicular angles, at 90-degree angles. They are perpendicular to each other. So the first one is 90. So we're going to write in 90 here. Okay. Now, what's the other one we know? Well, we know 2 and 3. 2 and 3 are going to be the same as each other because the diagonals bisect the vertices. So we know 3 is going to be congruent to 2, but we also know it's going to be equal to 58, okay? Because it's the same on both sides. Opposite angles are equal based on it being parallelogram, okay? So this is also 58 and 58 here. So we know 2 and 3 are both 58 apiece. Using that information, we can find the fourth one because we know that, looking for something here, we know that 90 plus 58 plus angle 4 needs to add up to 180. Why 180? Because we have a triangle in place here. Look. See, we have a triangle, so the interior angle sum of a triangle needs to be 180. So we do 180 minus, whoops, wrong thing, minus 58 minus 90 degrees, and that will tell us what angle 4 is. Minus 90 minus 58, and that will be 32. So this is equal to 32 degrees, angle 4. And we're done with example 1, based on mostly actually both properties for that. Example 2, we're mostly going to use the second property. Okay, so we're asked to find the angles. As you can see here, these angles are all the same. These are the ones that bisect each other. Okay, so how do we find 1 and 3? In the same way we find isosceles triangles. So here we have an isosceles triangle with 2 congruent sides. So what we need to do is we need to say, okay, 180 minus 104 will tell us the sum of those 2 angles, 1 and 3. So that's 76. Then we have to divide this by 2 because both those angles are equal, so we know that's going to be 38 degrees for 1 and 2. If that's 38, okay, then we also know that 2 and 4 are also 38 because those angles are also bisected, so we're done with example 2. It's that fast. Let's move on to the rectangle congruent diagonal theorem. This is our second special shape. So we say if ABCD is a rectangle, and this one's a pretty simple one, then, okay, and we know it's a rectangle because it says that all the angles are congruent, then we know that the diagonals are equal. So the angles are congruent, so the diagonals are also, well, that is a messed up diagonal. Let's fix that. Okay, and the way we can say that is we can say something like this. Okay, we know the angles, the diagonals are bisected because it's a parallelogram, and we also know the diagonals are congruent for a rectangle. So that's an important property for that. Our example 3 is pretty simple. We say AY, that's this first diagonal, is 2x plus 15. So we're going to write that in, 2x plus 15. Oops, wrong color. 2x plus 15. And then we have our second one. That is, what's the value of this one? 5x minus 12. And we're just going to set them equal to each other because it is a rectangle. We know it's a rectangle because we have 4 90-degree angles. So we're going to say 5x minus 12 is equal to 2x plus 15. 2x plus 15. I'd like to move the x's first to get them together, so I subtract 2x from both sides. I get 3x minus 12 equals 15. I'm going to add 12 to both sides. So I get 3x equals 27, divide by 3, and I get x equals 9. 9 times 3 is 27. Now, find the length of the diagonals. That x is not the length of the diagonals. We still have to plug this into either one. Since they're the same length, it doesn't matter. I'm going to choose 2x plus 15. So I'm going to do 2 times 9 plus 15 to give me the length of AY. And that is equal to 18 plus 15, or 33. So our length is 33 units for our diagonal. And that's all we have for today. That's all we have for special parallelograms. Hope you guys have been having a great new year, and I look forward to seeing you next time on West Explains Best.